Hey folks. Hope everybody's doing good. I'm just setting things up. Just give me 1 second and we'll get going here really soon. All right. So, welcome to Study Hall. This is a place for you all to come and ask your questions. If you have any questions from Learn, from around just wherever, if you want to explore a topic. I want to keep things, for my streams, I like to keep things constrained to beginner and intermediate Python. That's where we tend to notice people need the most help or where people benefit the most, in terms of preparing for the DSI. So since this is oriented around basic and premium prep material, I want to keep things kind of oriented around beginner and intermediate Python topics. Tovio will be streaming on Wednesdays. We're kind of working out a shared streaming schedule, so it's not just me. And we're going to kind of split them up between Tovio and I. So I think I'll be streaming every Monday and Friday, time permitting. Excuse me. Time permitting. And Tovio will be streaming on Wednesdays, time permitting, of course. One thing I did want to mention to clear up some, a number of people have asked me or have brought this up recently about study halls. And I just want to clear this up. So study halls are something that we do when we have time. So it's not an official. Actually, it's not an official part of what we do. It's sort of a secondary feature of what we do. So our primary goals are interviewing applicants, meeting one-on-one, continuing mentoring with students, facilitating prep, premium prep, basic prep, and pre-course. So that's what our team is focused on. So study halls are just sort of like an adjunct on the other things that we do. So just want to give folks a warning. We're not close to it yet, but as we start getting into interview season, start approaching the deadline for the interview deadline for the DSI, things are going to get busy, and it's likely that I'll need to open up my schedule for interviews and prioritize those. So I want to give folks plenty of warning on that, and I'll give other reminders as that day approaches. If I need to cancel study hall, I will let people know as soon as I can, because I know some people like these and like want to show up and come to them, which is great. I do foresee a world where study halls are more formally like a part of what we do, and they are going to go on absolutely consistently. But as of right now, that is not the case. So I did want to clarify that and just clear that up. So if you don't see us saying that we're going to cancel it, you can presume that we're going to hold them, and we're going to hold them whenever we can. Other things considering. So cool. It looks like we got some people showing up here. Hello and welcome. If you're watching, go ahead and throw an emoji or something in the Slack if you haven't done so already. It's just nice for me to see who's around and just know that we got some people hanging out and watching. Yeah, and I think even just that first Slack message kind of breaks the ice, as it were. You know, it makes it feel like you're here, kind of. You know. Yeah. So yeah, just to reiterate, the primary purpose of this is to give you all access, you know, a forum to bring your questions in, and we can clear things up, and I can take questions, offer explanations, explore special topics. That's actually another thing I wanted to mention. I'll do that briefly. I want to start writing. I don't know, I've mentioned this a couple times. I'm busy with a couple projects regarding just a couple projects that we're doing in the prep team, and for this week. But next week I want to write or maybe towards the end of this week, I want to start writing some special topics to explore in study halls, because I think that could be fun. So things like file I/O. I know somebody requested that, and I'm hoping I'll get to it either this Friday or next Monday. And then, you know, like just any other topics that you might want to know about. I have an object-oriented programming lecture that we actually cut from Premium Prep that I'm probably going to do at some point as well. Cool. So if you have suggestions on topics that you want me to explore, let me know and I'll write something up, and we can like make a thing of it. Cool. All right, so without further ado, that was quite a bit of ado. So no more ado. Without further ado, let's let's do some programming or something. Okay, so today I'm having another one of those days where I keep flip-flopping between whether I want to go through the learn material or go and do Code Wars problems, and I'll probably split it up. Yeah, let's split it up. So I'll start with some learn material, some Galvanize learn material. We are right still in the Python basics. This is just your first function, you know. So if you're in Premium Prep, you're well past this point at this point. But yeah, we'll go through this. It's never hurts to reinforce basics, and kind of look at information that you're already familiar with, because you might get a new perspective on it. So we'll go through this, and the floor is open. So if you have any questions, please go ahead and put your question in the Slack thread. If you're stuck on any problems in Learn, you know, just give me a link to the problem, and that'll help me find it quickly so I can help you answer your question. And of course, if you have any code of yours that you want me to troubleshoot, I'll go through it and pick it apart, and I'll try not to be too brutal. I know it can be a little scary, you know. Hey, eviscerate my code. It doesn't work. But I won't eviscerate it, you know. I'll be nice about it. But I'm just saying, you know, I know it can feel that way. So, all right, cool. So by the end of this lesson, I want you to be able to. Okay, cool. Sorry. Looks like we just got a question pasted in. Cool. So could you help me with challenge 3 in this link? Yes, I could. Let's go to that link. I have all these tabs open. Close all the tabs. Don't need any of those tabs. Okay. We're in. Looks like we're in sets. You're talking about sets. Good. Okay. So let's see. Write a function called continuous set. And I'm just gonna, this is some code from before. I'm gonna cut it and just, actually I'll paste it into my notes doc. here, just so I have record of it. I didn't look at it, I promise. Okay. So yeah, if you have anything, if you want me to look through your code or have any specific questions about this, feel free to put that in there. For now, since I just have the link, I'll just go through this and just kind of work the problem, talk about how I work a problem, and yeah, we'll just go from there. I'll do that. Okay. So write a function called continuous set. Def continuous set. Done. Print continuous set, and good. I think I'm going to set myself up here. Actually, we'll do res equals exp res. I want to make my test. So I know I do this a lot, where the problem starts with write a function called continuous set, and then I stop reading the problem and I go def continuous set, and I just write a pass and I say good, done. And part of that's just me trying to be cute, I guess, but I have this thing when I'm reading through a problem. Obviously, a lot of the problem solving you do while you're coding, you don't have a clear problem statement right in front of you. You have to think about the problem in order to solve it. But regardless of whether I'm working through a tutorial, which is something that you do, you work through working through a tutorial, or you're working through online material, which is what I do here, obviously, for my job, or if I'm just doing my own coding and I don't have problem statements in front of me, I will still write doc strings, which are essentially processed problem statements. They're a problem statement, except everything's clarified and everything. And I'm gonna basically try to cover like what what data I'm trying to process, essentially my inputs to my program or my project, what data I'm trying to process, what I need to do with that, and what the results need to be: input, process, output, IPO. So that's sort of that's that kind of perennial pattern that I have. And as I'm going through something, I'm trying to do everything that's obvious. And I notice what a lot of people will do is they'll read the whole thing and they'll sit there with no code written, and they'll sit and try to think about it. I'm not saying the person asking me is doing this. I don't know. I don't know how you, I haven't interacted with you outside of study halls that much, but so I don't know how you work. But this is a common enough problem-solving thing that I see that I just feel like I should mention it. So I'll see people like read the whole thing and kind of like sit there and go like, try to solve the problem in their head and conceive of a working solution and proof that solution before they start writing any code. And I don't know, maybe there's regions of academia where that's sort of the preferred way of doing things. I think if you're coming from a lot of engineering or math backgrounds, I think that's kind of the way you do things. But in programming, we have the editor, the terminal, the interpreter, all these tools to make our lives easy. So what I do, I have this rule, which is anytime I think I read something that just is kind of obvious, I just write it down, right? So this says write a function with this name, and I'm just going to do that. It obviously doesn't do anything yet. It doesn't even take inputs, but yeah, we're going to go from there. So you can see I just wrote the function head, just stubbed out the function, and I'm just writing a test down here, and I have to have an exp. If you don't know, this is my little shorthand. Res is for result, so it's the actual result of whatever this function is returning. So it's the result of that function, or the return value of that function. And then exp is what I expect it to return for a given set of inputs, which I haven't yet supplied because I haven't read the problem yet. So we'll just say x equals 0 just because well, let's do none just as a placeholder. Okay, cool. So write a function called that. This function should take a single parameter called set1. Okay, set1. And it should return a Boolean true or false depending on whether the set is continuous. Return is continuous. Okay, so I'm just kind of stubbing everything out, right? So let's see here. This is going to tell us what a continuous set is. A continuous set is a set that contains all sequential integers. So I guess this is going to limit us to just integers. So we're not going to be dealing with sets of words or sets of strings or sets of other types. We're just going to be dealing with integers. So for example, 1, 2, 3, 5 is not continuous because it's missing 4. So this is telling me this is a test right here. It's disguised as something else, but it's a test, right? So for example, whenever you read those words, you're probably about to see something that you can turn into a test. So 1, 2, 3, 5. So if I do this as an input, I should expect my expectation should be false. And then if I did 1, 2, 3, 4, 5, that should be true. Okay. Whenever you're testing a function that returns a Boolean, it makes sense to have at least two tests. That way you can test if your false case is working correctly and if your true case is working correctly. I could also see, potential errors. Like I could see writing this. I could see it being possible to write this wrong in a way that this wouldn't work, right? So I want to make sure that this test would work as well, right? So what happens if it doesn't start at 1? So yeah. So that's one thing. So for this is another continuous set, so I would want to make sure that's true as well. And then just for good measure, let's do 5 and 6. Okay. So this is going to be another false. And the way that I have these tests written, I'm going to see res equals x as a Boolean, which is just going to tell me true or false, right? So if this first thing that's printed out is true, then I know I'm getting the correct result. And then res in this case is going to show me what I actually got. That way, if I'm getting a false, if it's not passing, in other words, then I can see the result and I can tell why it's not passing. Cool. Okay. Let's get into it. So is continuous is false. So I'm just setting this up kind of as with this sort of pre-accumulator pattern. And I just assume most problems are going to be an accumulator pattern problem until proven otherwise. So I can think of a few ways to solve this. But basically, what I want to do is I want to find print the min. I want to be able to locate the min of the smallest number in the set and the max. So I'm going to see if min and max are going to work. And I know they will. I know these actually will work, but I want to make sure of that because well, I want to show you how you can make sure of that, right? I'm trying to show you like good, if you're like, well, if I got the min and the max and I use those as part of a range, then would that give me what I needed? So You can use min and max like that. And it's always fine to be able to just check your work, make sure to ask the interpreter, is this going to do what I think it's going to do? You can just print things out all day long. Okay, so we'll do min set 1 and max set 1. So what if I did, we know that's going to work. What if I did range min to max? Oops. Let's do this. Okay. So range 1 to 5, range 1 to 5, range 2 to 5, range 2 to 6. So I wonder if I just made this range into a set, which is kind of silly because a range kind of is a set because it doesn't have duplicates anyways, and I just set this equal to, if I ask if it's equal to set 1, because a range will generate continuous integers, right? So it's interesting. We've just got a mess of trues and falses here, but let's just mark this one. If you're ever getting too much output and you just want to see where something is, you can just mark something like that. I'm going to do this. Long arrow. Okay, so that's much easier to see. Okay, so false, 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 false. So that's kind of interesting, right? So you might have expected that if a range generates continuous numbers, why doesn't it equal? It never equals the set. And we know sometimes it shouldn't equal the set, but for these middle two, it should, right? So we should see false, true, true, false, right? So let's just, if you ever see something like that, you're not getting the result you think you should, just print out the values and let's see how they differ. Okay, so remember, first we're seeing the range, then we're seeing the actual set input. Okay, so we've got, so let's look at this one here, right? So we know that for this second one, and here, let me just constrain this down because right now I'm only interested in the true cases. Let's just constrain this down to one true case. You can always uncomment them later. Okay, so I'm getting false. So you can see I'm printing out the set of the range first, and that's printing 1 through 4, and my original set has 1 through 5, right? So this is a problem where the range does not include its upper bound, right? So I have to include that upper bound, plus 1, like that. Let's see, okay, so 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So that looks like it would work, plus 1. Whoops. So let me see if I can turn this false to a true like that. So there you go. There's true. So it looks like this is going to return true in this case. So I wonder, maybe I can just return that like that. Oops. Yeah, I've got a little mess here. Let me clean this up. Okay, that's better. Like that. Okay, now I like to add those spaces in there. I think it kind of spreads things out, makes it a little more readable. You don't have to do that. That's just a me thing. I think I'm the only person I know that adds spaces like it's like staged spacing in their code like this. So yeah. So oops, and I just deleted it. Okay, let's try that out. So true, true. Reminds me of that movie Cloud Atlas. If you've seen that movie, it's pretty good. Okay, cool. So you can see on the left now, I'm getting 4 trues. That's telling me that's res equals x, res equals x, res equals x, res equals x. So this is telling me my actual result is equal to what I expected it to be, which is good. That's a pass. That's passing the test. And then I can see the actual result that I got. And it's kind of funny because I'm using a Boolean to tell me if I passed, and I'm actually returning a Boolean. So false, true, true, false, and that's what we expect. Cool. So now at this stage, I've got code that works, but I've kind of got a mess up here. I've got some commented out prints that are kind of broken. We don't need these. These can go away. Get rid of this. We ended up not using is continuous, so let's just get rid of that, and we got this in a one-liner. Correct. That one works. Cool. Hopefully that was helpful. Now I'm curious to see, because I know I didn't do it that way. I think I must have helped somebody with this earlier. This is what I had before. I'm not sure why this code was this way. I'm not sure if somebody sent me this and I kind of tried to help them kind of solve the problem in the way that they were thinking about it. But I think evidently this will work as well. You can see it's a bit more steps though. Cool. Let me know if that was helpful for you, or if you have any further questions. Cool. Yeah, you're welcome. Glad that was helpful. Okay. Yeah, if anybody else has any other questions, feel free to pop them in there. And I know there's somebody who's saying they were going to pop in and ask some questions today. Doesn't look like they're online, so that's okay. Alas. Let's see here. Let's go through, I'm going to go through this functions lesson real quick, and feel free to just pop in any questions that you have, even if I'm in the middle of this. I'll finish this up, and then I'll take whatever question I see. All right, cool. So for this lesson, at the end of this lesson, we want you to be able to write a simple function and explain why functions are important. So we don't need to necessarily go through all this step by step. And I presume everybody understands kind of the basic principles of functions at this point. At least, for the people I see in Slack, I've seen these people around, and but yeah, I'll just go over this again basically. So the idea of a function is like, let's say, well, kind of the last example is not a bad example. So let's say in my project, whatever, I have a coding project, and I want to be able to see if sets are continuous. Well, I know that this algorithm set equals, and we could do like my set equals set of something like this, and then so if I say set range min my set max my set plus 1 equals my set, then I know that this will tell me I think I spelled that wrong. I'm not even going to try to spell it. Oh my gosh, I think I spelled it right. Wait. Okay. Good. So is continuous. We're just going to save this in a variable like this, right? And let's actually call it my set is continuous. So this is kind of a pain. Like, let's say I had to do this a bunch of times in my program. My other set so you can see this is starting to become tedious. So functions are there to save us from this tedium, right? And like this code doesn't, it looks ugly. I'm just repeating the same process in just sort of a more difficult way, So instead of doing that, and instead of remembering that every time I want to know if a set is continuous, I just get a range from the min of the set to the max of the set plus 1, turn that range into a set, and then see if it's equal to the set that I'm trying to see if it's continuous or not. And then that'll give me true or false as to whether that set is continuous. So rather than memorizing that algorithm, which it's not terribly difficult, but it's kind of a pain to write that line over and over. So rather than that, I could just save it into a function. I could just save it into a function, write it once, and rather than having to like put in my set into 3 different places every time, I can just put it into one place. I can say continuous set takes in some set, and then true or false as to whether that set is continuous or not. All right. So that's the utility of a function. It just allows us to abstract a complicated algorithm behind a simple interface, which is just the function name, right? So rather than writing the whole algorithm, I just say the function name and then pass in whatever necessary inputs that it needs, and then I get whatever output it produces. Cool. And while we're here, let's just revisit the anatomy of functions. So I think this actually can be useful, can be pretty useful to kind of revisit this. So we all know we have this def, well, maybe we don't know. We might have some beginners in here, right? So we have the def keyword followed by function name. So def just tells the Python interpreter that you're about to define a function. Then we have parentheses, and whether or not your function takes any inputs, we have to have the parentheses, even if it takes no inputs. and then return designates something to be an output. And your function technically does not have to have a return. It doesn't have to return something if it. I kind of use output and return kind of synonymously. So a function does not need an output. It's not required, and it does not need an input. Although it's fairly uncommon to write a function that doesn't have both. Even a lot of functions that don't have one have the other. I actually, as I think about it, it might be safe to say like if it doesn't have inputs, it probably doesn't have a return. But honestly, that's very rare. It's very rare that a function does not have an output or an input. Sometimes it's the case. A lot of times when you write a main function for your program, you can see I have a main function here. This is actually where I'm executing my code. So this main function doesn't have inputs and doesn't have outputs. There's a convention around doing things this way, and main often have inputs or outputs, although it can, depending on how you write it. It's totally fine to write main in a way that it takes inputs and out and gives it some output, but it's very common that it doesn't. So we'll gonna get away from that. So I guess what I'm trying to get at here is mostly the way you're going to think about functions is it's a process that operates on some data that you give it, that's an input, and gives some output. Some kind of rules of thumb here. If one of the inputs is a mutable type, you want to avoid mutating that input. If it makes sense to mutate it for whatever reason, just copy it first. So you'll do a .copy method. If that doesn't make sense to you, if you don't quite know what mutability is yet or what .copy is, we'll get to that, or feel free to ask me, and I can go over that principle as well, that property. Cool. So function. So we have def, function name. We have our region for inputs, and then we have our output. So let's just do something simple. Let's say subtract. I'm not sure. Subtract, we'll say a comma b, and we'll return a minus b. So this isn't, nothing fancy going on here, right? So if we look at this, if I run this code, I want you to notice that nothing happens. So this is something that I see a lot of times, where people, where people will define the function, and this is a lot of times like given a specific problem, like write a function to do some specific process. So like if prompted with some like write a subtract function to subtract this value from that value or whatever. It can be easy to forget that this does not actually ask Python to execute any instructions. This defines a process that Python could execute if you asked it to, but we're not asking it to. So one thing I want you to remember is, and I apologize, I keep thinking for a long time I've been trying to think of like good names for this, but the best term that I have for this is like phases. So let's think about functions as having two phases. One is the phase where they're defined, the other is the phase where they're invoked. So for the definition phase is where we define it. And then the invocation, oh, I don't know if that's a K. Okay, that's, I don't know. This is an I, invocation. Oh my gosh. gosh, my spelling is, that looks good. It's probably not right, but I'm going to go with it. The invocation phase is where we actually run it. So another thing that I'll see people do is they'll say, okay, so what's 5 minus 3? And then we'll run the code and nothing happened, right? And nothing happened because even though we ran the code, we didn't ask it to display anything. So if we don't invoke it, we don't ask it to do anything, just define a process, but not actually execute the process. So this just defines a generic process. This executes that process with specific information, 3 and 5. 3 and 5 are specific. Those are concrete values. A and B are generic. They're not values. They're just names that could have values when I invoke it. So we can see 5 is going to be plugged into A and 3 is going to be plugged into B. So this will actually ask it to run, but it won't ask Python to display the information. So you got to remember to print, right? And thus we have a test. So, and I recommend this, return from your functions, print your invocations, and that's a good kind of basis for a workflow. So this will say 2. And just to prove this, so if I switch the input order, right, then 3 is going to be plugged into A and 5 is going to be plugged into B. So that order of the inputs matters as well. Oh, somebody's asking me to increase my volume on my headset. I have it set up so that it's just right before it's peaking. I'm worried that if I change it, I fiddled with it a lot to get it right here because I have multiple points to adjust it. But yeah, can you turn it up on your end anymore? I'll increase it, but I would suggest trying to turn it up on your end before I do that because I won't want to get into a whole thing. Actually, shoot, that does kind of look low. Dang. What am I going to do? Okay, I'm going to increase it just a little bit. See if I can do this just a little bit. Check, 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 check. Check, 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 check. Okay. We'll leave it there. All right, hopefully that's better. Actually looks better on my end too. Cool. Okay, cool. Let's just jump through these challenges real quick. Okay, so again, I'm going to work out of my editor because that's where I prefer to be. Let's put this in a doc string. Define a function called mod 5 times 6. The function should take a number as an argument. I'm going to call it n. And let's print mod 5 times 6. We'll give it, let's just give it 10. As an argument, perform the operation mod 5, the operation modulo by 5. Oh, wow, okay. Perform the modulo by 5 operation, multiply that result by 6, then return the new result. Okay, so let's return n mod 5 We want to do that, and then whatever that result is times 6. And I'm not sure what to expect for this, so we'll just go with that. Oh, looks like we got 0. Is that really what I want? Well, that's interesting. Oh, of course that makes sense, because, yeah, these numbers were multiples of 5. Yeah, okay. Well, let's see then. Let's do for I in range 50. No, I'm just curious. I'll do I, oops. Okay. Yeah. Looks like we get this pattern 0, 6, 12, 18, 24. That makes sense. Cool. So I think that'll do it. Let's try it. There we go. Finish writing the function func, which should take argument x and return 5x plus 7 squared. Okay. Return x times 5. We'll do it more like they have it written 5 times x, so that's our 5x. And, oops, 5 times x. And then we'll do plus 7. We spread this out a little bit, plus 7. And then we'll square it. We'll square the whole thing. Cool. Define a function called lots of math. Doesn't look like that much math. This says calculate, and then that'll be x squared times x plus 3. So presumably like this. Okay. I think it's just going to be that. Define a function called lots of math, def lots of math. Whoops. We'll take one parameter called x. The function should calculate, convert the result to an integer, and then return the result mod 7, return int mod 7. Okay. I'm not going to bother with testing because, you know what? I don't want to. Okay. Variables overview. So I've been using variables inside and out all day long. So variables are very straightforward. I think this is still worth covering because I think there's some terminology that I use that can be easy to forget. So let's just talk about the anatomy of a variable. So something as simple as a equals 10. We've got a, which is the identifier, or sometimes called the sometimes, a lot of times, it's just referred to as the variable. Or the name. The name of the variable, whatever. So I'll usually call it the identifier if I want to be specific, right? Then the equals is going to be the assignment operator. So this assigns a value from the right and assigns it to the value in the left. And then 10 in this case is the value. So a value being assigned by the assignment operator to the identifier. There you go. So it's useful to just kind of have that clear idea. So the value is any expression that expresses a value, an int, a float, a bool, whatever, a list. And it can be just a literal like this. It could be when we use a variable that's created, wherever we use that identifier, that name, that expresses the value that was assigned to it, right? So it could be another variable. So, right, like b equals a. It could be a more complicated expression like c equals the eighth, not eighth, but eighth root of b. B squared. So c equals b squared, the eighth root of b squared. It's hard to say eighth without it sounding like eighth. They just sound the same to me. Okay. So yeah, that value can just be any complete valid Python expression that gives back a value. Cool. I think it's useful to have names for things. I like kind of being able to know what things are called. That helps me think about it, you know. So even though variables I think are probably a really simple topic for y'all, I think it's worth just kind of revisiting identifier, assignment operator, value, you know, kind of knowing how those things are referred to. Not just so you can talk about them, but like I said, I think it helps me organize my thinking. So variables. Learn how to declare a variable, identify when a variable is needed. So we just looked at declaring a variable. This is declaring. Right? Let's see, when are variables needed? I would say variables are useful to if you're gonna write something like a function call, like let's say a good example is like sorting a list. Sorting as like there's a whole class of algorithms for sorting algorithms, and there's sort of a famous like computer science trope to like practice, not really trope or what tradition, or what am I trying to say? Like it's a classic like computer science learning thing to like write sorting algorithms. Um, if you've never written a sorting algorithm, you can like look it up. Maybe I'll have a study hall devoted to like writing different sorting algorithms. There's a whole bunch of different sorting algorithms, and it's really interesting because um, they tend to be, I think we think of them as being very simple operations. Oh no, did I lose the stream?